Welcome to day 5 of 100 days of coding. Today we'll understand three main concepts: bitwise operators, membership operators, and identity operators in Python. Now, for an overview, what are bitwise operators? These handles binary operations including AND, OR, XOR, NOT, left shift, right shift. Membership operators checks for membership in sequences like list and tuples. Identity operators determines whether two variables reference the same objects. Next, to be in detail, bitwise operators refer to those which manipulate binary representation for efficient computation. This includes AND, OR, XOR, and NOT with varying logics. Shifting operators are another type of bitwise operators which have left shift and right shift used mainly for multiplication and division calculations. Now an example of bitwise operator example code is as follows. A is 60. So 60 when converted to bitwise binary representation is 00111100, and B is 13, which when converted gives 00001101. Now the bitwise AND will result into A and B, which is 12. So as a result, the result is 12. Bitwise OR, on the other hand, is to check whether this or that. Similarly, bitwise XOR is to check NOT OR. NOT operator is to check whether this is not of that or not. Next, common use cases for bitwise operations. It is used in data encoding and compression. Bitwise operators help in efficiently encoding data by manipulating bits directly. An example for this is, supposingly you have two variables A and B. A is apple and B is orange. Now if you want to check whether A is B, so you can write bitwise of A not B. If it comes false, then you know A is B, and if it comes true, then you know A is not equal to B. So that is the reason why it is true. It is used mainly in data encoding and compressions, flags and bit mask, graphic, image manipulation. These are some examples of bitwise operations. Now, supposingly, what do we mean by data encoding? Encoding and decoding, there are two types of it. Encryption refers to data encoding, which is manipulating bits directly and can significantly reduce the size of a data need for transmission. The times when we resize PDFs, these are all data encoding. We are resizing it using bits. Flags and bit mask. In system programming, bitwise operation allow for use of flags encapsulated within a single integer value, making it easier to track multiple state conditions. Like suppose in some conditional programs where a particular program is checked to know whether this particular condition is matched every time, we use flags to encapsulate it. Now what happens in that case is that particular integer value is checked and is kept track of to ensure that the value does not change, and if it is changed, then which kind of state condition it is facing. Next we have image manipulation. We all know what image manipulation is. Now in bitwise case, the pixel data manipulation is known as image manipulation, and graphic manipulation refers to graphic programming which is used to do this image manipulation. Next is understanding the use cases. Now, if unlike traditional arithmetic operators, the efficiency of bitwise operators is far better, especially in performance critical applications. The difference between both is bitwise operator manipulates individual bits for efficiency. Arithmetic operators perform standard mathematical calculation. Bitwise manipulation and arithmetic calculation, they are not similar. Understanding the difference is crucial for selecting the right technique based on computational needs in your program. Example of bitwise operator practical implementation, as we can see, is in graphic and encryption application, logical outcomes, bit manipulation techniques. Next, applications of bitwise image processing can be done using bitwise operators. Network protocols, data compression, cryptography, game development, artificial intelligence, these are just some applications of bitwise operators. There are more which can be used. Now let us go to the second part, which is membership operators. Now what is membership operators? Such as in and not in. if a, suppose there is an variable named a, it's a string variable, and it has the word apple. Now if I'm writing check if a in if the letter a is present in the variable a which has the word apple. Now if it is present, then it will return true. If it is not present, it will return false. It is used to check if an element present in sequence like list, tuple or strings. Working mechanism is that the in operator checks for existence while not in checks for absence. Performance efficiency, it is usually O of 1. The time complexity of membership operators is O of 1, while in list it can be O of n. Membership operators. Now in detail, when we are saying, they serve as a very essential tool in Python, allowing developers to determine the presence of elements within sequence. Now suppose if you want to check if a particular pattern has the asterisk itself in it, you want to make an asterisk pattern, and if you want to check whether the asterisk is present in each line or not, you can use the membership operator to do it. These operators are primarily utilized in various data structures like lists, tuples and strings sets, making them versatile in handling diverse programming scenarios. The in operator effectively checks if an element exists in a sequence, while not in confirms its absence. This distinct functionality aids in constructing clearer condition statements. It is important to note that membership checks it sets offer O of 1, which is the time complexity of O of 1 is providing a significantly faster process as compared to list, which can take up to O of n. So for sets it's faster than it is for list. Understanding these little time complexities enables us to optimize the code. Now let's see examples for better understanding. For its basic usage, suppose there is fruits apple, banana and cherry. If apple in fruits, print apple is present. So what will it print? Apple is present because in the list apple is present. Now similarly, in case of string and tuples, this can be used as follows. Suppose text is hello. If E in text, print character found. So in this case, the output would be character found because E is present in hello. Conditional logic also if we can use. Suppose for fruits in fruits, if fruit not in banana and cherry, print fruit. This allows to check if the first part which we saw, fruit, apple, banana, cherry, if banana and cherry are present in the fruits set, then only it will print it. Now to understand this better, let us see a very common example of voting. If supposingly we are taking the age from the user, and the age we say that enter the age of the user and please enter your age. Now the user enters an age below 18, then what are we going to print? Sorry, not eligible to vote. So we can check if 18 is present in that particular variable which is accepting the age from the user. If it is not, we can print no, not eligible to vote. If it is yes, we can print yes, eligible to vote. Example of membership operators, it is basically used in codes for clarity in programming. Membership operator is basically to check whether a particular element is present or not. So it can be used in strings and tuples as well. It is used mainly in conditional logic with memberships for better data applications. Now let's go to the third part, identity operators. As an overview, identity operators in Python, namely is and is not, are used to determine if two variables refer to the same object in memory. Behavior of is and is not. This operator evaluates to true if both variables point to the same object, while it not checks for different object identity. Practical applications is what? Identity operators are vital for managing singleton patterns and immutable types in Python. Now, details about identity operators. The definition is and is not. Like in membership operators is in and in not. In identity operators, it is and is not. So, if it checks whether it is same as the other operator or not. So, how does it does it? With is and is not. Two conditions. Return values are true if both refer to the same object, and false if both refer to different objects. And for is not, it is again true if both do not refer to the same objects, and false if both do refer to the same objects. Now it is useful in comparing singletons and immutable types. Memory address compares the memory address. So what does it does is, in identity operators, is or is not, they compare the memory address of the two operators. Common is to confuse is with double equals to for value comparison. It is not the same thing. Now, let's see an example of identity operator to understand the concept better. In Python, identity operators are used to compare the memory addresses of two objects, allowing you to check if they are the same object in memory. Below is an example code demonstrating the use of is operator. Now list1 is 1, 2 and 3. List2 is list1.copy. What is list1.copy? .copy function refers to copying all the elements in list1 and pasting them as it is in list2. Now we are going to use the identity operator to check. If list1 is list2, print both variables point to the same object. Else print both variables point to different object. The simple example highlights the concept of identity operators in Python and sets the stage for further exploration how the function in scenarios involving memory address works. Examples of identity operators. Memory address comparison. Two identical lists, list1 and list2, despite identical values, evaluates to false due to separate memory. Now supposingly if list1 is 1, 2, 3 and list2 is equal to 1, 2, 3. This time when I am checking identity is not, my answer will be false when I'm checking for is, if list1 is list2, because the memory address is not same any longer. So identity operators is used to check if they share the same memory address. List1.copy ensures that list2 has the same memory address as list1, so the evaluation comes to true. Now it can be also used to check singletons, where a class has only one instance. Example, if object is singleton.instance, it checks whether that singleton is an instance of that object. In practical coding scenarios, it helps in accidental modifications, mutable objects, then it prevents bugs. Every time that bugs are fixed, identity operators are generally used. In summary of operators, comparatively speaking, operators offer varied functionalities for data manipulation in Python. It is very important to know operators in Python for fundamental logic and algorithm. And you can further increase your knowledge by going through different books and other examples available online. Thank you.